started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be talking about files, specifically how you can read from and write to files in your Python programs. But before we get into those details, we need to talk a little bit about files themselves. To start with, what are files? Well, a file is a container for persistent data storage on your computer. By persistent, we mean it's not going to disappear when your program restarts. And this is great for storing information like text, images, videos, and much more. All kinds of different things can be stored in files in different formats. And this gives us a great way to save and organize our data for easy access and later reuse. So why do we use files? Well, a big thing is that they keep the data permanently. So far in the course, all the data we've been storing has been in variables. But the problem with variables is once your program restarts, they're gone. So files allow us to keep that data persistently. So the next time we run the program, the data is still there. And this makes it easy to open, edit, and share information with others or with other programs. Next, we need to know how we refer or reference a specific file. And we typically do that through its file name. So every file on your computer is going to have a unique name within its specific folder. We also sometimes call that a directory. And when you're looking at files, you'll often notice that their name contains what we call a file extension. These are those letters that occur at the end of the file name, and they usually follow a dot character. This isn't required. We can have files that don't have a file extension, but it does give us a useful little label to give us a hint at what's in the file. For example, report.txt gives us a hint, even without looking in the file, that this is probably a text file that contains plain text that a human reader could read. But it is important to note that the file extension doesn't do anything special. It's just part of the file name, and we use that to give us a guess or a hint at what it contains. Changing the file extension doesn't change what type of file it is. Another thing these extensions are used for are guessing what program to open up the file in. For example, your operating system may take a look at the extension like .txt or .png and use that to guess what sort of program to open the file in. For example, if it ends in .png, it might open that in an image editor or an image viewer. If it ends in .txt, it might open it in something like a text editor like Notepad. But again, changing that file extension doesn't mean that you can't open this file in those programs. It just means that your operating system isn't going to know what program to open them in. Changing the file extension has no impact on what's actually stored in the file. To give an example, if we had a photo called photo.jpg and this stored some image data, and we renamed that to photo.txt, this doesn't suddenly make that a text file. If you tried to open it up in a text editor, you wouldn't see an image or something like that. You would probably just see a bunch of binary data. So I can't stress this enough, as it is a common error many students make. The file extension, changing it doesn't convert the file. It's just a hint or a naming convention we use to give the reader an idea of what's in the file. What's important is the data that's in the file. That defines what the file actually is and what it stores. So I have a list here of some common file extensions. Some of them you may be familiar with, like docx for a Word document, or image files like .png or .jpg. But again, these just are useful labels that we put in files to give us a hint at what's in them. Having one or not having one or having the incorrect one doesn't mean that it's suddenly a different type of file. The next concept we need to discuss are file paths. And the idea here is that this is the full location to where the file is stored on your hard drive. It's sort of like a map to a specific spot or file on your computer. We said that files have a unique name, but only within a specific folder or directory. The file path tells us exactly what directory they're in, and when we combine that with the file name, we get a true unique reference to that file. Here's an example for the full path to a file named report.txt, and this is for a Windows operating system. It's important to note that different operating systems might represent their paths slightly differently. For example, this is what it might look like on macOS or Linux. This is conveying very similar information, the location of where report.txt is on this computer or this hard drive, but each operating system might have a slightly different syntax for this and a slightly different way that it sets up drives. For example, in the Windows example, that C colon at the beginning means that this is located on the C drive, whereas Linux and macOS doesn't really encode that in the file path. So what does this file path actually mean? Well, each part in the path represents a folder or directory, sort of like nested boxes or folders, leading finally to a file at the end. So in this first example, we have a number of directories that are nested inside of each other. First, on the C drive, there's a users folder, and inside that users folder, there's a second folder named user. Inside that user folder, there's another folder named documents, and inside that documents folder, there's a folder named school, and inside that school folder, there's a folder named project. Finally, in that project folder, there is a file named report.txt. So this is giving us the full map to where we can find that file on the hard drive. And the idea here is just like boxes or folders, they can be nested inside of each other to any real depth. And even though this path only shows one file, keep in mind that there could be many other files or folders in each one of these. This is just explaining where this specific file is. This works the same for other operating systems. For example, in this Mac OS example, the same thing's going on here. Home is a directory, and inside home, there's a user directory. Inside that, there's a documents directory. Inside that, there's a school directory. And finally, inside that, there's a project directory, which has the report.txt file. So it's important to keep this in mind when we're talking about files, so we know how to locate them. When we don't include the full path to a file, and we just say the file name, that typically means that the file is in the current folder that we're working in. Sometimes we call that the current working directory. The last property of files we need to discuss before we can get into some Python programming are binary versus text files. And we'll get started with text files. So text files contain plain text that's human readable. By human readable, we mean we could open this in any text editor and have a good idea or understanding of what it contains just by looking at it. And these usually use some sort of standard encoding scheme like ASCII or UTF-8. We won't be getting too in-depth into these in this course, but just know these are ways for a computer to encode text data in a way that we can understand. So let's go through some common examples. The one you may be familiar with already is the .txt or plain text file. This file doesn't have any syntax or encoding rules. It's basically just raw characters encoded in ASCII or UTF-8 in a file. This is what something like Notepad would make if you were to just type some text into Notepad and then save it. The next ones are tab-separated values and comma-separated values. These are a way of encoding data in a file that can be read by both humans as well as the computer. And they are sort of a tabular form of storing data, like a spreadsheet, but a lot more primitive. The way these files are encoded are that every line in the file is a different row of data, and each column of data is separated by a specific delimiter character. For tab-separated values, this delimiter is the tab character on your keyboard. For comma-separated values, it's the comma character. Let's take a look at an example. And here we have grades.csv. This is a comma-separated values file. And here we can see every different line in the file represents a different row of data. In this case, that data are grades and student numbers and a name for specific students. So each line represents a different student, except for the first line, which is a header line that basically explains the format of the file to us. Each column of data is separated by a comma character. So on the first line, you can see name, comma, student number, comma, assignment 1. Each one of these are different columns. There'd be a name column of all the students' names. There's a student number of column with all the different student numbers for the students. There's an assignment 1 column with all the different grades for assignment 1, and so on up to final grade. What's great about files like this is we could open them up in something like Notepad, and we could understand them. For example, we can see Alice here's a student. They have a student number of 001, and on assignment 1, they got an 85. And we can see their final grade is an A. So we can understand them as a human, but a computer could also read this file and interpret that data and use it in our programs. Some other common text file types would be HTML, hypertext markup language, which is what we use for encoding websites, as well as XML, the extensible markup language, and this is more of a system for encoding structured data. The complement to text files are binary files. Text files were meant to be human readable, while binary files are in many ways the opposite. They contain data in a format intended just for computers. They're not meant to be read by humans. And these usually don't use a standard encoding system like ASCII or UTF-8, Instead, they define their own encoding scheme. The reason they do this, rather than just make everything ASCII, is that this often gives us many advantages in terms of efficiency. The files tend to be smaller, and they might be able to be read and understood easier by a computer. The downside, other than not being able to read them as a human, is that they often require specific software to read and interpret. The software understands the rules or encoding scheme used by that specific file format, so it's able to interpret them. However, programs like Notepad or a plain text editor on your computer wouldn't be able to understand those files, and you would just get gibberish as a result. Let's take a look at some common examples. And the first one is a PNG file. And this is a file format for storing images. But let's take a look at what might happen if we were to try to open this in Notepad and try to interpret it ourselves as a human. So what this image actually is shown in the top right. It's a smiley face emoticon. However, if we were to open this in Notepad++, because it's not encoded in ASCII, we would get a lot of nonsensical output like this. And I don't think there's any people that would be able to read this and interpret that as a smiley face emoticon. The reason for this is that we need to use specialized software to understand these binary formats. The specialized software in this case would be something like an image viewer, or maybe even a web browser or word processor that's been configured to understand this sort of encoding. Some other examples are audio like MP3, video like MP4, as well as executable programs like .exe for Windows. Now we're going to move on to actual Python programming, and we're going to start learning about how we can read from files. Before we can read or write to a file in Python, we have to open that file for access. And the way we do that is with the built-in open function. The open function takes two main parameters, the file name and the access mode, and it returns a file object, which is an object that allows us to interact with the file, such as reading from it or writing to it. The syntax for this function looks like what we have on the screen right now, which is open, and then it takes two parameters, file name and mode. The file name, as you've probably guessed, is the name of the file. And we have an option to give a full path to the file name or just specify the file name. If we just specify the file name, Python's going to look for it in the current working directory, which is typically where you're running the program from. If we do give a full file name, like a full path to the file, then Python will try to access that file at that specific path. The other option is the access mode. And this tells Python if we're reading from the file, writing to the file, or what sort of access mode we are using to interact with that file. On the screen now are some of the most common access modes that you're going to need while working with files in Python. Each access mode is a string of one or more characters that represents how we're going to interact with that file. The first access mode we have listed here is R, which is for reading. This opens the file in a read-only mode, and if that file doesn't exist, then it is going to raise an exception. The next access mode is W, and as you may have guessed, that is for writing to a file. In this case, the file doesn't already have to exist. If it doesn't exist, it will make that file, and it will fill it with the data that you write to it. If the file does already exist, it's going to delete that file and replace it with a new file, meaning it's going to overwrite the contents of the file. So if you're using W mode for writing, make sure that you are writing to the right file because you don't want to delete something important. The last mode I'll talk about is Append, which is represented by A, and this works just like writing, except instead of deleting a file if it already exists, it starts writing to the end of the file. So this allows us to update our files instead of just wiping them out. Let's take a look now at a basic example. This example only has 2 lines of code. The first line you should already be familiar with. It's storing the string example.txt in the variable named file path. Note that in this example, this variable name doesn't really matter. It could be named anything we want. We could call it name, we could call it f, we could call it path. Any of those would be fine as long as we're consistent with it. On the next line, we're opening this file. So in this case, the file is named example.txt. Since we don't give a full path, Python's going to look for this file in the current working directory. You'll also notice that we are giving an access mode of R, which means that we're reading from this file. So it's going to be opened in read-only mode. So to summarize, this attempts to open the file example.txt for reading. And this will raise an error if example.txt does not exist in the current working directory. So a common problem a lot of students have when they first start working with files is not having their text files in the right directory. This looks like something is going wrong because it's going to raise an error, something about file not being found. And this often means you just haven't created that file yet, or you don't have that file in the correct directory, so Python can't see it. So now that we've talked a little bit about opening files, we also need to know the complementary concept, which is closing files. And closing files is important because after working with a file, we need to tell Python that we're done with it and that it should finish writing everything to that file and save it properly. If we don't do this, there's a chance that the file could become corrupted, or Python hasn't finished writing all the data by the time the program exits. This is also important because it helps us free up system resources. For opening a lot of files, closing them when we're done with them means that the system no longer has to keep track of them in their memory. The way we close a file is with the close method, and we use this close method on the file object that we got from the open function. Let's take a look at an example. So here we have the beginning of that example we just saw. We are opening a file named example.txt, and we're going to reference that file using the file object named file. Then we do whatever we want with that file. In this case, it's just represented by a comment that says code that reads or writes to from the file. And when we're done with that, we want to close the file. And we use the close method. And we are using that on the file object that we got from open. So in this case, file.close means that we close the file. It's important to note that after we close the file, we can no longer use that file object to work with that file. So once the file is closed, you'd have to open it again before you can write or read from it. Let's now take a look at how we can actually read from a file. And the simplest way to do this in Python is with the read method. When we use the read method on a file object, and we don't give it any parameters, it simply reads the entire contents of the file and returns that as a string. This gives us a very simple way to retrieve all of the data from a text file at once. Let's take a look at an example. This first line here is simply opening the file. In this case, the file is called hello.txt in read mode. And then we get a file object that we can use to actually reference this file and read from it and close it and do other operations. So in this case, let's say the hello file is fairly simple. It just has a few lines of text, like hello world, welcome to Python file handling, and so on. The next line of code actually calls the read method on the file object. So file object is the object that was returned from open. And like I said, it allows us to actually interact with the file. By calling read, it's going to read all of the lines at once from hello.txt and return that as a string. And that string is going to be stored in the variable content. So that might look something like this. It's going off the screen a little bit, but it says hello world, a line break, welcome to Python file handling, a line break, and so on. So it's important to note that when we read from a file like this, we do get the line break characters at the end of each line. Here I'm showing them on the screen now so you can see where they would have been in the file. So when we read from a file, we also get those line break characters in our result. The next line simply outputs this to the console, which would look just like the file does, but this is being output in the Python console rather than on the screen. And then the last line closes the file. Like I said, it's always important to close files after we have worked with them. Using the read method like this is fairly simple and straightforward, but it does have some downsides. Since it reads the whole contents of the file into a string at once, this can cause some pretty significant problems if this is a large file. Reading a massive file into Python into a string could use up the computer's memory and not be very efficient. In many cases, it's more beneficial to read the file one line or one value at a time, rather than reading the whole thing at once. Reading one line at a time can also be really helpful if we need to do some processing. For example, like that comma-separated file we saw earlier with student grades, we might need to process that file to get specific students' final grade. If we read it in like this, it would be really hard to determine what Alice's final grade was, because it would just be a big block of text in a string. So now we're going to look at some methods that allow us to process a file one line at a time. And that method is going to be readline. The readline method reads one single line from the file at a time, so that gives us more control of how we move through the file. And readline, as you probably guessed, is going to return a string containing the line. But it's important to note that this string is going to include that new line character at the end if there was a new line character in the file. So each time readline is called, we move to the next line in the file. You don't have to specify which line you're reading. Each time the file pointer moves to the next line, and the file object keeps track of what line you're currently reading from. This is useful because we can keep calling readline over and over again and get the next line of the file. When there's no more lines left in the file, readline simply returns an empty string to signal that it's at the end of the file. This can be very useful when we're reading large files, line by line, without loading the entire file into the computer's memory. For extremely large files in the gigabytes range, this is necessary to be able to process them without running out of memory in your computer. So let's take a look at an example of using readline to read from a file. And the file we're going to read from is the same one in the last example, that hello.txt, but this time we're going to use readline to read one line at a time, and we'll read the first 3 lines from the file. So we start with the open command to open the file in read mode. We've seen that before already. But what is new are these read lines. So this first line here, line 1 equals file.readline, is going to read just the very first line of the file. It's going to return the string hello world with a line break at the end and store that in line 1. The next line reads the next line of the file. Remember, the file object keeps track of where it was left off, so each time you call readline, it moves on to the next line of the file until it reaches the end and returns an empty string. Next line is going to read the third line of the file. Now, because we don't have any more read lines in our code here, we're only reading in the first 3 lines. Line 1 is going to be stored in line 1, line 2 in line 2, and line 3 in line 3. And as you may have guessed, this part is going to just output those lines to the console. So we get something that looks like this. But notice there's these extra spaces underneath. Why might that be? Well, it's because, like I said, we are also reading in the line breaks from the file. Each one of these lines in the file has a line break character at the end that we can't normally see, and that is going to be read in with that text, which means that when we output that variable, like line 1, line 2, or line 3, it's also going to output that extra line break. So if we were able to see the line breaks, they would look something like this. The ones I have in red are line breaks that we read in from the file, but remember the print command also by default adds a line break. So that means these blue line breaks are coming from the print command. So we're getting one line break that we read in and one that we're adding from print, which is why it looks like we have an extra space after each line. So how can we deal with those extra line breaks that we're reading in? They could cause some significant problems if we're reading in more complex data, like integer and floating point values, and we need to convert them. That conversion would break if it had a line break in the text. Well, luckily, we already covered some string methods that can help us. And one of those is the strip string method. If you recall from that unit, the strip method removes any leading or trailing white space, which includes line breaks, from a string. So if we read a line in from a file and then we use strip on it, it will remove any white space at the beginning or the end of that string, which includes line breaks. This can be quite useful because it will remove any of those extra spaces that we might get in the file and allows us to concentrate on the data. Let's take a look at an updated version of that last example, which uses strip now to remove those line breaks. You can see these have been highlighted here. When we call strip after readline, it means it reads the line in from the file, removes any white space at the beginning and the end, and then stores that result into the line variable. So the first one is going to store that into line 1, then line 2, and so on, and then we print the results out like we saw. So now when we run this, instead of getting those extra lines, we just get the line break that print is adding. We don't get an extra line break from the file. The last method that we're going to take a look at for reading from a file is readlines. So to be clear, that's with an S on the end, plural. And this method is very similar to readline, except that it reads all lines from the file. But unlike the read method, it is going to return a list of strings. And that list's elements are going to be a string for each line in the file. So if there's 10 lines in the file, we would get a list of size 10, with each element of that list containing a string for that line. Keep in mind that just like with the other methods we saw, this is going to include any new line characters that we obtained from the file. Let's take a look at a simple example. So again, we're reading from that hello.txt file, and we're in read-only mode. And what's interesting here is using read lines. So we have the file up here again, just to see how this is going to work. And each one of those lines in the file is going to become a new element in line list. If we were to print this out, we would get something that looks like this. So here we can see that each one of these is a different element in the list. The square brackets denote that this is a list. And we can see the commas show where each new element starts. So hello world would be the first element. Then we have welcome to Python file handling would be the second element. This is the third line of the file, will be the third element, and so on. But keep in mind that those line breaks were read in, so if we wanted to remove those, we'd have to process this list to call strip on each element. So this can be useful because we could then use this list with a for loop, or we could use this list with any other kind of method or function that handles lists. The next topic we're going to take a look at is how we can combine loops with files to allow us to loop through each line of the file one at a time and then do some processing on that line. In the examples we've seen so far, we sort of hard-coded each read from the file. That might work for very simple files that have a finite number of lines, but if we don't know how big our file is, we're going to need some logic to loop through it until we get to the end. And there's a few different ways we can do that in Python. The first way we can do that in Python is with a for loop. And luckily for us, the for loop is already built to work on file objects. So just like a for loop will loop through a list or a dictionary or something like that, we can also use a for loop directly on a file object, and it will loop through each line in the file. This approach is really great because it efficiently reads from large files. Instead of reading the whole file in at once, we only read one line at a time. Let's take a look at an example. Here we're going to read from a new file called to-do list. And this file will just have a few tasks that are part of our to-do list. In this example, we just want to read them in and then print them out again. Nothing too exciting, just to give us an idea of how the for loop works. And we can see the for loop down here. And this looks like the for loops we've seen before, except instead of a typical sequence or collection of some kind, we are passing it the file object here. So again, this doesn't have to be called file, it's just whatever the name of your file object is. And that is the object that's returned by the open function. So in this case, we stored the result of the open function in file, and then we use that in the for loop to say we're going to be looping through the lines in this file. Then the loop variable is going to be called line here. Again, you can call it whatever you want, but the loop variable is going to be set equal to the current line in the file. So the first time this runs, it's going to be equal to buy groceries. Then the second time, it's going to be complete Python homework. Then the third iteration, it's going to be called the dentist for an appointment, and so on until we reach the end of the file where the loop will terminate. This line here simply prints the result, as well as calling strip on it to remove the line break, because just like with everything else we've seen, the line breaks are included. And the output would be pretty much what you expect. It's going to go through, and each loop, it's going to output a new line from that file. We're not just limited to looping through a file using a for loop. We can also use a while loop. And this is accomplished using some of those read methods that we saw before, like readline. And using a while loop versus a for loop has a few different trade-offs, and it gives us some different flexibility. We have to use the right tool or the right loop for the job. And readline is great for this because it has that feature we talked about before, where once it reaches the end of the file, it returns an empty string. That's important because that can be our condition for our while loop. If we return an empty string from readline, we know we're at the end of the file, and then we can terminate the loop. So let's take a look at an example. And this example actually does the exact same thing as the last example, except it accomplishes it now using a while loop and readline rather than a for loop. The first line simply opens up that to-do list file that we saw before with all the different tasks, and it's the next line that starts getting interesting. This is our priming read. And this is the same as those priming reads we saw before when we were processing user input, except instead of from the user, it's taking that input from the file. In this case, it reads the first line of the file and then stores that in the line variable. The next line here is the header for our while loop. And what it says is that as long as line is not equal to the empty string, we're going to keep running this loop. Remember, line's going to be equal to empty string when readline returns that it's reached the end of the file. So this loop's going to keep running until we reach the end of the file. Inside this while loop, we're going to print out the value after stripping it, which just means we're going to remove the line break. And then we're going to do our update read. That means we're going to read the next line of the file. So this would get the second line, and it would store that in line. So the value of line would be updated to the second line of the file, and then the loop restarts. And it's going to keep doing that loop again, keep reading one line at a time, until it eventually reaches the end of the file, and readline returns an empty string. Then when the while loop restarts, it's going to see that line is equal to the empty string, so it will terminate, and then we finally get to file close. So here's what the output would look like. It's the same as the last example. We're just copying what's in the file and outputting it to the console. Now, one thing I should point out is we're not limited to just using one strategy or the other. We can use both readline and that for loop in the same program. And the way these interact together is that the file object keeps track of our current position in the file. So if we do a few readline calls before the for loop, it means that for loop is going to start off where we left off in the file. So if we read the first 2 lines using readline, and then we loop through the file, we'll be starting on the 3rd line of the file. Each read advances the file pointer further and further in the file, and each time we do a read, like with read, readline, readlines, or with a for loop, then we continue off where we left off in the file. This is useful because it means we could process lines differently. For example, if the first 2 lines of a file need to be processed differently than the remainder, we could use readline to get those 2 lines, and then use a for loop to loop through the remaining values. This is a common occurrence in files like comma-separated value files, which may have a header line at the beginning that we might want to skip or we might want to separately process. Let's take a look at an example problem. Let's say we had some more complex data like this. This is mygrades.data, and the idea here is this is a file that's going to store the grades you've obtained in all your different computer science courses. It's formatted such that there is a header line, the first line of the file, and it's always going to have the text course, a space character term, a space character, and grade. The remaining lines are going to be the different courses you've taken and the different grades you've obtained in them. This is always going to be the course code, a space character, term code, a space character, and the grade as an integer value that you obtained in that course. There could be one or more of those different courses in the file. So how could we process and read in this file using this combined strategy of using both readline and a for loop? Let's take a look at the solution. And here's the solution to the problem. The first line we should already be fairly familiar with. This just opens the mygrades.data file in read-only mode. The second line is where things get a bit more interesting. What this line does is it reads in a line like we've seen before, but in this case we're not doing anything with the result. We're just throwing it away because we're not assigning it to a variable. That's perfectly valid and allowed, but it might seem like it's a little bit useless. But there is a side effect to doing this that is important, and that is that this advances the file pointer. So now when we do a further read, like a read method or a readline method or a loop that loops through all of the values in the file, then we are going to start at the second line rather than the first line because we always resume where we left off in the file. This is important for this for loop that comes next. Because we've already read in the header, that means this for loop is going to start at the second line in the file. And what this for loop does is it simply prints out each line with any white space removed at the beginning and the end. It does that using strip. So the output would look something like this, which is the file, but with the header removed, because we read it in, but we didn't output it or do anything with it. Then finally, we close the file. So let's put all of these techniques that we've learned together and try to solve a more complex problem. And this is going to use that grades file that we saw before, but now we want to actually do something with it. So the example problem is you have your grades for all your computer science courses you've taken so far in a file named mygrades.data. You wish to write a program to read this file and compute your average grade. The first line of the file is a header row. The remaining lines each contain values in this order: the course code, the term code, and your final grade rounded to an integer value. The file will contain the grades for one or more courses, and we want to output what your actual average is. So the file looks like this, just like what we saw. Let's now switch over to PyCharm and try coding this. Okay, I have PyCharm opened up, and we're going to start working on a solution to this problem. I have the text of the problem pasted in here as a comment, but everything else is blank. And we have mygrades.data, and this is that file that we saw in the slides that we're going to try to read in. An important note here is that mygrades.data is going to need to be in the same directory as grades.py, or where we're running the program from. So in your PyCharm project, make sure mygrades.data is in the same directory as grades.py. So to get started, we're going to have to open up this file before we can read from it. And we do that with the open function. Let's call this grades file. And we'll use open. And the first parameter or argument that we're going to send it is going to be the file name. In this case, that's mygrades.data. And we're going to be opening it in read mode, which means that we're going to have read-only access to the file, which is fine because we don't need to write to it. So what do we have to do next? Well, we'll notice that this has a header, and we're going to want to skip this header because if we try to just do this for a for loop and interpret each one of these as an integer, it's going to be a problem if we try to interpret the text grade as an integer value, because we actually need to read these values now to find the average. So what we're going to do is skip this header. And we can do that fairly easily, just using that readlines method that we saw in the slides. So what this does is it reads in this first line as a string, but we don't do anything with the result, so we just sort of throw it away, but it does move the file pointer to the next line. So the next time we read from the file, we're going to start at the second line. We don't know how many lines this file will always have. In some cases, it could have thousands of lines. In case it could just have one. So we're going to have to loop through it. But before we do that, there's some things we have to keep track of. Since we're trying to calculate an average, we're going to need to know how many lines there are, as well as how the total of all of these grades. So we won't know how many lines there are at the start, but we can keep track of a counter that's going to increase every time we read a line, and we can keep a total of all the numbers we've seen so far. Then at the end, we can divide them to get the average. So we'll use a variable called total to store that total in, and we'll use a variable called count to store how many lines we've read in so far. Next, we need to do our loop logic. So in this case, we can just use a simple for loop. It's a for line in grades file. And this loop is going to run through each line of here, starting with the second line because we've already read in the header. So for now, just to test this out, we'll just put a print. And remember, you should always test as you go. So we're going to see it does this output the lines we want in the file. And we can see we're getting the lines. It is adding that space. If you remember, there are line breaks that we can't see in this file after each line. And those are being read in. So we get one line break from the print and one line that we read in from the file. So the first thing we might want to do is fix that. And that's fairly easy to do. We can do that with the strip command. Strip removes any leading or trailing white space, including line breaks. So if we give this a second run, we can see we don't get those extra line breaks now. But we don't want to just print this out. We're going to want to actually process this line. And the problem we have right now is that when we read in a line, we're getting this string that is the whole line. But we only really care about the grade at the end, because that's what we're trying to complete the average of. So there's a few different ways we could approach this, but the easiest is probably to use a string method that we've already learned about, which is split. Remember, split allows us to give a delimiter, and it will split the text at that delimiter. So in this case, this is not really a standard file format, it's just one we came up with, and we have a space after each value. So if we split this line, add a space, we should get 3 values: the course code, the term code, and the grade that we're after. So let's do that with split. And when we don't give any values to split, by default, it's going to split at white space. And that's exactly what we want in this case. So just to test that out, let's put a print back. And actually, let's save this to vowels. And we'll print out vowels, just to see what's going on right now. Okay, so we can see what split has done. So it's taken this line that was read in by the for loop, and we've stripped the line breaks, and then we split it. And you can see that that has resulted in a new list that has 3 elements: the course code, the term code, and the grade, which is good. And we can see it's doing this once for every loop. So now we have these separated. Let's actually run this in debug mode because we can get a little bit better understanding. And we'll step in. So we can see here that vowels is equal to this list. So index 0 is always going to be the course code, index 1 is always going to be the term code, and index 2 is going to be our grade. And that's what we're really after. So now whenever this loop runs, we know that the current course code is going to be in vowels 0, the current term is going to be in vowels 1, and the current grade is going to be in vowels 2. And this is a great way to process data like this. It also works with other file types. You just have to split on different characters. If this was comma separated, we would put a comma delimiter here. If it was tab, we could put a tab here, and so on. In this case, it's just a space, so we can leave it as the default. So now that we have each of these data elements, we want to actually add these grades in our total. Now, one approach we could try would just be total plus equals vals2. Remember, that's where the grade is. But this is going to cause an error. Let's take a look. See, we get a type error, unsupported operand type, or S, int and string. So what's happening is what we got from split isn't an integer value. We've got the text or string with the characters 6 and 5 in it. We don't actually have the number 65. So just like when we input values from the user, we're going to have to cast these into the correct type. In this case, we could do that with int because we know these are always integers based on the problem description. So now we're counting the totals, but we also want to count the lines we've seen so far. So we're going to add 1 for each line we encounter in the file. So hopefully after this loop is run, we should have the total number for all the grades added together, and we should have a count for how many grades there were. Then we can use this to actually compute the average. Average equals total divided by count. If we wanted, we could be a little bit more careful and put an if statement here just to check if count was 0, but the problem did say that there's always going to be 1 or more grades. So we won't add that error checking now. You could always add it on your own if you want. It's a simple if statement. And we want to print out the result. Which grade is, we'll use an F string. And we probably want to round this, at least in the output. So we'll say 2 decimal places. If you remember your F strings, this means we're going to get the value of average, and we're going to display that with 2 decimal places. This doesn't change the value of average, it just changes how we display it. So let's see how that works. And we got your grade, your average grade is 80.50, which I believe is correct for that file. Now there is one thing that we're forgetting here. Do you know what it is? We forgot to close the file. So this isn't really that big of a deal when we are working with the file in read-only mode. But if we were to do this when we're writing to a file, we could actually get a corrupt file, or Python might have not finished outputting everything to the file yet. So it's always good practice to close your file, even if it's in read mode. So that last line is going to make sure the file is closed. And we should get the same result. And we do. Okay, so this program seems to be working now. Let's switch back to the slides. And we're back. And in the slides, you can find a copy of that program, except in this version, I've also added comments to explain everything. You can also find a copy of this attached to our learning management system if you want to test it out yourself as a Python file. So now we're going to look at one last way to read from files. And so far we've seen reading a file all at once using read, as well as reading a file one line at a time. But it's also possible to read a file one character at a time. And the first time we saw the read method, we don't give it any parameters or arguments, it comes back with the whole file as a string, which can be useful for some simple cases, but for more complex cases or really large files, it's a bit of a problem because it'll use up the computer's memory if it's a really big file. So another way we can use read is by giving it the number of characters to read in. So if we say read 1, it means it's going to read in a single character. We can take advantage of this to go through a file one single character at a time. Let's take a look at an example. In this program, we're going to be reading a file called python.txt, and that file is going to be very simple. It's just going to have one line of text that says Python is fun. We're opening it with the open function. You know this already. And where things start becoming different are this first line here. So we are reading in the first character of the file. This is sort of the priming read for the while loop that's going to happen. In this case, since the first character is a p, that p is going to be stored in the variable char, C-H-A-R. Now, this while loop is going to keep running until it reaches the end of the file. And just like readline, when read reaches the end of the file, it returns an empty string. So what we're checking here is, are we at the end of the file? Is char an empty string? As long as we're not at the end of the file, we're going to keep running through the file one character at a time instead of one line at the time. Here, we're going to print out the result. So the first time this loop is run, it's just going to output a p. That's the one character we've read in. Then we're going to read the next character in the file, which in this case is a y. And then when we loop again, we output that y. And this keeps going through each character, one character at a time, until eventually we're going to hit the end of the file and an empty string will be returned. But keep in mind, there is a line break there as well. So after the line break, the next character will be the empty string, and then we exit from the loop and close the file. So you can see in this case, the output is going to be Python is fun, printed one character for each line using the print command. This example isn't too useful, but in other cases where you want to process a file by one character each time, this can be a great approach. Let's take a look now at a more interesting example that reads a file one character at a time. And the goal here is there's going to be some text in a file, and we want to count the frequency of each letter. By frequency, we mean how many times does that letter occur, and we want to do this in a case-insensitive way. So we have the solution here, but we're going to try this out in PyCharm to get a better idea of how it works and to debug it a little bit. Okay, we're back in PyCharm, and this time we have example 7.2 loaded up. And what this does is it's going to go for a file. The example we have here is called mixedtext.txt, and it's going to try to count how many times each letter occurs. But we only want to count letters, and we want to do it in a case-insensitive way. So we don't want to count things like spaces or commas or other things like colons. Now this program uses a little bit of a different approach in that we're going to actually use a function to do this. What this function is going to do is it's going to take a file name, it's going to process the file, and it's going to return a dictionary. That dictionary is going to have a key for every letter that we found in the file, and the value will be the number of times that that letter occurred. Down here, we have the code that actually drives the function, just as an example. So we'll start here before we look at the function. So we're calling the function that we defined above, and we're passing it the file name mixedtext.txt. Having a function that takes file name like this is great, because it means we could use this for other files as well. The return of this function is going to be a dictionary, like I described before, with all the frequency counts. And we're going to store a reference to that dictionary in char frequencies. Down here, we have some code that just loops through the dictionary and outputs it. In this case, we're using .items. So that means we're going to return a list of tuple values for each key value pair. And we're using the sorted function to make sure this is sorted in order. So we'll get the A's first, then the B's, then the C's, and so on. Otherwise, it would be in whatever order they were encountered in this file. And since this is a list of tuples, we can use tuple unpacking to get both the key and the value here, and then we print them out. If you want to know more about dictionaries and looping through dictionaries like this, please see my dictionary video where we'll go into more depth in how that works. So let's take a look at this function now. And rather than just try me describe it right away, let's actually try running it in debug mode so we get an idea of what's actually going on here. So let's set a breakpoint and we'll run it in debug. Okay, so we've paused at the breakpoint, and we can see all we have right now is this parameter that's coming into the function, and the argument we passed it is mixedtext.txt. This is going to be the file name. This line that we're on right now is going to read in, or open rather, that file, so in return a file object that we can use to work with the file. And we can see the file object is represented here. In this case, we're just calling the file object f. The next line is going to create an empty dictionary for us. When we run that, we can see we have a dictionary called counts that just has nothing in it. There's no key value pairs. So the next line is going to be using the read method to read in a single character from the beginning of the file. The one here means how many characters we're going to read in. If we leave it out, it reads in the whole file. But since we have one, it means it's going to read a single character. Keep in mind, this number doesn't mean which character in the file, it means how many. So since we're at the beginning of the file right now, the first character is going to be the capital letter H. So let's try running that. And we can see that we get a result of char equals capital H, read the first letter, and it returned that, and we stored it in the variable char. The next line is the start of our while loop, and we're checking is char not equal to the empty string. And we can see it equals H right now. So that means we're going to enter into this loop, and this loop's going to keep running until we hit the end of the file. We know we're at the end of the file when read returns an empty string. So let's continue on. Now, what we want to do is we want to check, is the character we're currently on actually a letter? If it is a letter, that means we want to count it and add it to our dictionary. If it's not a letter, like a space, a line break, or a punctuation mark, like a period, that means we want to ignore it. And one of the string functions we've already covered that can help with that is the if is alpha method. This is only going to return true if this is a letter. So in this case, H is a letter, so we should enter the if statement. If it was false, we would skip over these lines and go and read the next character right away. Since it is a letter, we're going to enter into that if statement. And the first thing we're going to do is we're going to convert that character to uppercase. In this case, that character already is uppercase, so nothing's going to change. But for other letters like this lowercase e here, it would make it an uppercase letter. This is important because we want both a lowercase e and an uppercase e to count as the same letter in our frequency count. So we jump to the next line, and here we are checking if the character is in counts. Remember, when we use an in keyword on a dictionary, which counts is, it's checking is the value of char a key in our counts dictionary. So is there an entry in our counts dictionary that we defined up here with an H as the key? Since count started as an empty dictionary, there's not going to be, so this is going to return false, and we run this command here. If it was true, then we would run this command here. The statement is adding 1 to the count, so if the key already exists in the dictionary, we're going to add 1 to its value. Otherwise, if the key doesn't yet exist in the dictionary, we're going to add that key to the dictionary, and we're going to start its value at 1. So in this case, it doesn't exist. So we're going to jump down here, and we'll see this dictionary be updated with a new key value pair. And you can see that it got H equals 1. So that means we have an H key, and for that key, we're storing the value 1, and this represents how many times we've seen an H so far. Now we get out of this if statement because we ran out of statements, and we're going to read the next line. This is our update read. Again, we're saying 1, so we're going to read in 1 character. And remember, file keeps track of where we were. So we were on H, we're doing another read, so now we're going to get lowercase e. And you can see it has been updated to E. We redo the while check. In this case, it's not equal to empty string, so we go again. We're checking, is it a letter? It is. Now we're going to convert that letter to uppercase. This matters in this case because we had a lowercase e. And you can see it's been updated to an uppercase e. We're checking, is it in our dictionary? In this case, it's not, so we're going to add it to the dictionary with a value of 1. We can see our dictionary has now been updated to include an E. Let's just go through a few of these now. So we're continuing to read the file, 1 character at a time. And we are updating our dictionary each time. You can see how we are getting more. This one we just read in a comma, and we skipped that comma because it's not a character, so we didn't do anything to the dictionary, we just jumped right to the next character being read in. Got a space, so we jump again. This time we get a W, we add that to our dictionary. Now we got an O, a lowercase o. That is a letter. We convert it to uppercase, which was important because now it matches this O here. This time O is in the dictionary, so we run this first part. And now we're going to update the value for O rather than add it again. So O becomes now having a value of 2 because we saw another O. And it's going to keep going through all the lines in that file. And you can see our dictionary keeps growing, as well as the values being updated for each time we find a new letter. Okay, now we're at an interesting point in the file. Right now, we just read in the period character, which is right here at the end. So we're going to run one more time. It's not a letter. And now we're going to read in a character, but we're at the end of the line. So let's see what happens. And you can see that we have a empty string equal to char right now. And this means this is going to cause the while loop to terminate. What happened is read hit the end of the file, so it returns an empty string. And we're checking, is it equal to an empty string? So now it is. Since we said not equals, this means we're going to exit out now. And we jump down to closing the file. And then we return counts. Counts is our big dictionary that we built up down here of all the different letters we saw in the file and the number of times we saw them. So what just happened here? Well, my breakpoint was inside of the function, so when we reached the end of the function, the code just resumed and ran everything. So in this case, our dictionary was returned, and then it was printed out by this code here. And you can see that in the terminal now, which gave us a nice count for the number of times each letter occurred in the file. For example, A occurred 3 times, E occurred 10, L 7, and so on. You might notice that some letters are missing, like B, and that's because there was no B's or Z's in this file, so they're not included here. If we wanted to code this in a different way so it did include every letter but had like a count of 0, the correct solution would be to initialize our dictionary with every letter first and with a count of 0 first. But in this case, we just wanted the letters that were actually in the file, so that's fine. Let's switch back now to the slides. And we're back. On the screen right now, I have that same output that we got when we ran this in PyCharm. If you'd like to test it out yourself, this program is on the Learning Management System, and you can try it with a new file, or you can try it with the example file. Maybe you want to trace through it just to get a better understanding how this works. Now we're going to move on to writing files. And the first step in writing files is just like the first step in reading files, which is that we have to open the file. However, when we're writing to a file, we need to make sure that we're using a mode that supports writing, such as W or A. The W mode, or write mode, creates a new file or overwrites an existing file. So that means if this file already exists, it's going to replace it. The other mode, A, or append mode, adds content to the end of the file instead of replacing the file. So if the file already exists, it's going to start adding lines to the end, just like if the file pointer was already at the end of the file. Let's take a look at an example. And in this case, it's pretty straightforward, just like we've already seen, except we are using W now instead of R as the access mode. One thing that we should really stress is when you're using W mode, make sure that you have the correct file, because you don't want to be deleting or overwriting a file that you want. So my recommendation is never put a Python file in this as a file name, because it could wipe out your code. Always make sure you have the correct file, and it's not a Python file, because you don't want to delete the code you're working on. So now how do we actually write the text to the file once we have it opened? Well, we also have a write method that does probably what you expect, and it writes a string to a file. Keep in mind that to do this, you have to be in a mode that supports writing, like we just mentioned. So write takes a string as an argument, and then writes that string directly to the file. It writes that string wherever the file pointer currently is. So just like in reading, how the file pointer moves as you're reading the file, when you're writing, the file pointer will move to the end of the last string that you wrote to it. So each time you call the write method, it's going to write the next part of the file. Now, one thing to keep in mind is that if we're trying to write a value, like an integer or a floating point value, we need to convert that to string before we pass it to write, just like we would when we're trying to add it to a string. Because write takes a string argument, so that means if we have an integer, we're going to have to use something like the string function to convert that integer into a string before writing. Let's take a look at an example. This example is fairly basic. We're just opening a file called greetings.txt in write mode. That file didn't exist, it would now create it. And then we are writing 3 different lines using the write method. So this would end up looking like this, the file. It would say, hello Python learners, welcome to file writing in Python, happy coding. But there are a few things to note here. And the first are these line breaks. Now the write method, unlike the print function, does not add line breaks for you. So if you want these values to be on different lines in your file, you do have to manually specify where each line break is. If you leave these out, everything will just be on one line in the file. So when using write, remember to add line breaks where you need them. The other thing is closing the file is critically important when we're doing writing. If we don't close the file, Python may have not finished writing to it yet when the program terminates, and we could get corrupted file or we could get some of our data missing. So if you want to ensure the integrity of your file, make sure you always close the file. It's good programming practice too, because it cleans up some of the things in the computer's memory that are related to that file. Now we can also use write in append mode. In the last example, if that file already exists, it would have overwritten it. So in this example, we're doing something a little bit different. We're generating some random number, and then we're just writing it to the file. But in this case, we're writing it in append mode, or A here. So this means if the file exists, we're not going to just overwrite it. We're just going to keep adding new lines to the file. Each time we run this program, a new line is going to be added. So the first time we run this program, the file will contain your random number is 2. If we ran this program a second time, the file would be appended to, and we'd get a new line in the file. In this case, it says your random number is 8. If we ran the program yet again, then we would get a third line added. In this case, your random number is 4. So Append Mode keeps adding new lines. Now we can also do writing in a loop, just like we could do with reading. And this is a common task when we have some sort of data structure that we want to output into a file, such as we might want to loop through a list and output all the elements in a list to a file, or loop through a dictionary and put out all the key value pairs into a file. So combining loops and write can be quite powerful because it allows us to do some interesting things when we're writing to files. So here's an example of writing out the data in a dictionary to a file. In this case, we have a pretty basic dictionary. The keys are different products, at least the names of the different products, and the values are the different prices for those products. The goal here is to create a new file called product catalog, and this program will output all of those product names and prices into that file. Note that we're opening it in write mode, so if this file already exists, it's going to be overwritten. Next is our loop. And what this loop is doing is it's looping through all of the key value pairs in the dictionary. .items means that it's returning a list of tuples, one tuple for each key value pair, and then this is using tuple unpacking to put the key in product and the value in price. So each time we run through this loop, we'll have a different product name in product and a different price in price. Then inside the loop, we use file write to write this f string to a file. The f string just makes a string, so we can use it with write, just like we do with the print statement. Again, we include that line break at the end because it doesn't add it for us. After we run this code, the contents of product catalog would look something like this, where we have all of the different keys written out, and then they're followed by the different value, which is the price. We also added a $sign in our f string to make the formatting look a little bit nice, and we made sure everything was displayed with 2 decimal places. It's important to note that we're not limited to just reading a file or just writing a file. We can do both at the same time. We can also have multiple files open at the same time using the open command. And this is really useful because one of the common tasks that we see a lot in programming is reading from one file, doing some processing on it, and then writing it out to a different file. So we're going to take a look at an example that does just that. So the example problem we're going to try is to process a file called studentgrades.csv. This is a comma-separated values file, and it's going to contain the grades for a number of different students for a variety of assignments, quizzes, and the final exam. Each line is going to represent the grades for one particular student, and the values on these different assessments are going to be separated by commas. So the very first column is going to be the student's name, and the remaining ones are going to be different grades on different assignments and other assessments. So your program should compute the student's final grade based on the following weightings. Assignment 1 is 10%, assignment 2 is 15%, the quiz is 20%, and the final exam is 55%. We want to write our output to a new comma-separated values file, and that's going to start with the student's name, then their final grade, and then finally if they passed or failed the course. And that's going to be represented by pass or fail, the actual text. So here's an example of what studentgrades.csv might look like. The first line is going to be a header row that explains the name of each column, and that's going to be followed by one or more students. We won't know for sure how many. And each one of those lines is going to have the student's name, followed by their grades for each assessment. And this is always going to be a floating point value rounded to 2 decimal places. So let's switch over to PyCharm now and see how we could code this. Okay, we are in PyCharm, and I have a mostly blank Python file open. We just have a comment explaining the program, and we just have those weights from the description here stored in a list. These are stored as percentages between 0 and 1, so 0.1 would be 10%, 0.15 would be 15%, 0.2 20%, and so on. We also have the student's grades file, which is that comma-separated values file. And it's important, once again, that this is going to be in the same directory as where we're running the program in our PyCharm project. So the first thing we're going to need to do is open up some files. First file we're going to need to open is studentgrades.csv, which we're going to be reading from. So we'll call that input file. And we open it, give it its file name, which is student grades, and we're going to open that in read mode. Now, what's different in this example is we're also going to be writing to a file, and we're going to be doing that at the same time. So we also need to open a file for writing. So we'll call that output file. And we'll call this final grades.csv. And in this case, we're going to open it in write mode, which means if this file already exists, it's going to write over it. And if it doesn't exist, it's going to create that file. So now we have our files open, we're going to have to do something with them. And the first thing we're going to do is probably skip this header. We don't really need to do any processing with it, so we'll skip that with a read line. So in this case, it's part of our input file. And we're going to use read line. And that should skip the header. And we're not going to do anything with that result, but it will move our file pointer now down to the next line. So now we want to loop through each one of these lines and compute the overall grade for each student based on those weightings. So to loop through each line, a good strategy is to use a for loop. So line in input file. And remember, we are starting on the second line because we did that read line already. So now what do we want to do for each one of these? When the for loop reads it in, it's going to be stored in line, but it's going to be stored as a big string. So we're going to want to separate these values so we can actually process them. And like we saw in the previous example, a good strategy is to use split. So we can say, or just call it grades. That's going to be equal to line. And the first thing we probably want to do is to strip off any line breaks, because remember at the end of each one of these lines, there is that invisible line break character, and we don't want that. And then we're going to use split. Now, last time we saw split, we just used the default value, just a space. But in this case, a space isn't going to work because this file format isn't separated by spaces, it's separated by commas. So what we're going to do is give it comma as the separator character, or the delimiter, we also call it that. So this is going to break this string down wherever there is a comma, and it's going to break it into a list of strings. So we'll get the first element Alice, then 88.5, then 92, and so on. So let's just give this a try and print out what that list looks like. And we'll run the program. And you can see we're getting a bunch of different lists. Each one is being produced each time that loop runs. And you can see split is correctly breaking it into the different values. But keep in mind, these are currently string values, so they're going to need to be converted if we want to do more processing on them. And this is going to be in the same order as these headers. So the student name is the first element, assignment 1 is the second element, assignment 2 is the third element, the quiz is the fourth element, and the final exam is the last element. Now to compute the final grade, we have to use these weightings up here. And we could just type this out something like final grade, and then go grades 1 times weights 0. And that would compute at least the first part of the final grade for grades 1, which would be the first assignment, times weightings 0, which would be at 0.1, 10%. Now we could keep writing those lines, one for each different assessment, but that's a bit of a pain. What if we added another assessment in here? Then we'd have to alter our code. So it'd be better to write this way that is a bit more generic. But there is one thing we should look out for, and that is these aren't at the same indices. So for grades, starts at 1 because we're skipping the student's name. But weightings start right away at 0 because that is the first percentage. So we're going to have to keep that in mind. So what we're going to do is we'll start off final grades to be, let's say, equal 0. And then we're going to add to it for each assessment. And we're going to loop through each one using a for loop. And we are going to use a range so we can keep track of the index because we're looping through two things at once. the weightings as well as the grades. We're going to start at 1 because our grades are offset by 1 because of that name. And we're going to go to the length of grades. So actually, I should call this just final grade because it's just for one student, the current student that we're on the line for. Now inside this loop, we're going to want to do two things. We want to compute the final grade, one assessment at a time, and we also want to do something else. We want to know how many assessments there are. Because we could be adding more assessments on in the future, we want this code to be generic enough so that if we added a new assessment, we wouldn't have to alter our code. So we'll also keep track of a count to know how many assessments there are. There are other ways we could do this, but this is fairly straightforward. First thing we'll do is we'll add 1 to the count. And now we want to calculate the final grade. So in theory, what we need to do is keep adding the grade from here, because they're all out of 100, and multiplying it by the weight and adding that to the final grade. After we go through all the different assessments, we should arrive at their final grade. So the first thing is going to be their grade at the current index. So the first time this loops, it's going to be assignment 1, then assignment 2, and so on. And we need to multiply that by the weighting for that grade. Now, if we did this, we would have a problem for a few reasons. The first one is that these don't line up. The weights indices start at 0, whereas grade, really it starts at 1. The reason why is because that first slot of grade 0 would be the student's name. So to make these line up correctly, we're going to subtract that index by 1. So when this loop first runs, I is going to be equal to 1. So we'll get grades at 1, which will be assignment 1. But we will get weights at 0, which will be the first weighting, which is for assignment 1. Multiply them together and store the result in final grade. Or actually, I should say we add the result to final grade. But there is another problem here, and that is grades. You see, grades is going to be a string when we first read it from the file. So if we want it to be a floating point number, we are going to have to convert that. And we can do that with the float function. And I like a little space here. Okay, so now at the end of this loop, we should have both a count, how many grades there were for that student, as well as the total final grade based on the weightings we have up here. We're going to assume that these correctly add up to 100%. Now we're going to want to actually output this. We've calculated the student's final grade, but we need to actually write that to a file. And we can do that in the exact same loop. So we'll actually be writing as we process it. So we say outFile.write. And the first thing we're going to write is going to be the student's name. And that is going to be stored at grades 0, because that is the first column. The next thing is we want this to be comma separated, so we're going to put a comma, and then we're going to put their final grade. And we'll display that with 2 decimal places of precision. And lastly, we're going to want pass or fail, if they passed or failed this course. We haven't figured that out yet. So for now, I'm going to say we're going to have a variable called pass or fail. It's going to store if they passed or failed. Now let's figure out if they passed or failed. So that's making a decision. So we likely need an if statement. So if their final grade is greater than or equal to 50%, we're going to say they passed. Otherwise, if it's less than 50%, we're going to say they failed. And that's going to be the last value in the output file. Now there is one thing we have to do, and that is close these files. And that's going to be even more important because we are writing in this case. So we'll start with the input file, we'll close that. And we have output file, and we close that. Okay, there is one bug that I left in this program. Can you see what it is? It does have to do with how we're writing out the file. Let's give it a run and see what happens. You'll notice that when we run this, we get no output, but that's expected. We don't have any print lines in this code. This program purely reads from a file and writes to a file. It doesn't output anything for the user. So we'll have to go into our project and actually open up that file, and we can see what we got. You'll notice there's a bit of a problem here. This is supposed to be a CSV file where each student is going to be on its own line, but everything's just on one big line in this file. The values themselves look okay, but it's all on one line. So what went wrong? Well, it has to do with the write method here. Write doesn't work like print. It doesn't include a line break for us. The reason why it doesn't include a line break for us is so we could use it in other ways, like outputting a single character at a time. However, in this case, we're trying to output a whole line at a time, so we do want a line break, which I just added. Let's see what happens when we run it a second time. And we can see now everything is put on its own line. The reason why this worked when we just ran it a second time is because we're in write mode, so we're not appending to the file. We're going to actually replace the file with the new output. And you can see here we get Alice, which is going to be from grades 0. Then we get the final grade, rounded to 2 decimal places, which is the result of this part of the F string. And then we get pass or fail. In this case, pass. You see they got an 84, so they passed. This person down here got a 42, so they failed. And Kurt down here also failed because they only got a 23. So our program does seem to be working correctly. And I highly recommend, if any of this is confusing, download the program yourself. I should also have a copy I made earlier on the learning management system. And then try running it yourself. Maybe run it in debug mode so you can see how everything works as it runs. And we're back. And of course, I have the solution in the slides, and it's also attached to our learning management system. In this case, the solution's about the same, but I added extra comments so you can get a better idea of what's going on if you're just reading the text. The logic's basically the same. Some lines might be slightly different order or slightly different style, but it generally does the same thing as the last example. There are equivalent programs. I also have the example of the correct output here, and we also have all of those example input files attached to our learning management system if you'd like to try them out. That's all I have for you in this video. I highly recommend that you try the examples and try coding out your own programs that read and write to files. Best way to learn programming is through actually trying it yourself and writing your own programs. It's not just about memorization. Thank you for watching, and have a great day.